In this presentation, we're going to continue on with our review of differentiation, and in particular, what we're going to look at in this presentation is the product rule. So I'm also going to change notation a bit. So I was using F and F dash a lot in my previous presentations. What I'm going to do is I'm going to change to the other type of notation, dy dx, just for the sake of brevity. Also because it sort of suits this particular explaining this particular rule as well. So suppose I have some function y, okay, and it is the multiple of two functions, for example u of x and v of x, where u is a function of x and v is a function of x. The derivative of y, dy dx, which is the alternative notation, is equal to u times the derivative of v, so we have dv dx there, okay, plus v times du dx. Okay, so it's one times the derivative of the other and just add them both up. It's as simple as that. Okay, so what we're going to do here is question 20, and y in this case, in the book actually, or in the notes, it's actually written as f of x is such and such is equal to, but I'm going to just use y just to sort of keep consistent with what I've just said there. X to the power of 4 plus 4x plus 2 times 2x plus 2. 2x plus 3, okay? So here what I'm going to do is let u equal to that first term there, and that's the second term there, and both of them are functions of x, okay? So in this instance what we're going to do here is get the derivative of du and dv. So first off, let's start off here. Du dx, I'm just going to go through this very quickly. This is 4x cubed plus 4. Okay? 4x cubed plus 4. dv dx is simply 2. Okay? So what we're going to do now is multiply them out. Essentially multiply one by the other. Okay, make a little bit of room there. And what we have here is derivative of dy dx. So dy dx is u, well, it doesn't really matter which order they come in, but I'll just sort of stick what we have here. X to the power of 4 plus 4x plus 2 times the derivative of the other one. The derivative of v is simply 2, okay, plus v, which is 2x plus 3, times the derivative of the other one, which is 4x cubed plus 4. Okay, so it's sort of straightforward enough. Really all we have to do is multiply them through. That is equal to 2x to the power of 4 plus 8x plus 4 plus 8x to the power of 4 plus 8x, okay, plus 12x to the power of 3 plus 12. Now essentially what we do is just collect up all of those terms there. Okay, so the x to the power of 4 terms, we have 2 of them there. So that is 10x to the power of 4. Then we have an x cubed term there, just the 1, plus 12x cubed. We have 8x and 8x, so we have plus 16x. Okay. So that is those two terms there. There's no x squared terms, so there's no x terms. So the last thing we have to do is just add in 16 there. Okay, 10x to the 4 plus 12x cubed plus 16x. Okay, so that's that. So that's the first one there. So we'll move on to the next one here. So that was question 20. So now we're going to do 21. Something very similar. Y, and again I'm just changing notation here just to sort of emphasize that I can use both. 3x squared plus 2. Okay, so what we're going to do here is let u, that equal to u, and that equal to v. Let's get the derivative of u. Du dx is equal to 2. Okay, so that's 2 times the derivative of x is 1, so 2 times 1 is 2. The constant term there is 1, so 2 minus 0. Okay, so it's just 2. The v dx is 6x plus 0. Okay, so that's just using the power rule. And let's just put it all together. Dy dx is u, which is 2x minus 1 times dv dx, which is 6x, plus v, which is 3x squared plus 2 times du dx, which is 2. Okay, and again, multiply them out. What we get here is we get 12x squared minus 6x, and here we get plus 6x squared plus 4. Just group them all up there. We get 18x squared minus 6x plus 4. Okay, and that's the answer to that second, or number 21, the second one for this presentation here. Moving on, we'll just get through these all. So this is 22. Let's have a look at this one. Again, something similar here. F of x, and again, actually, sorry, I'm going to use y still. Just keep it y for this entire thing. This is x cubed minus 12x, okay, times 3x squared plus 2x, okay. Again, we're going to let this equal to u and that equal to v. Du dx is equal to 3x squared minus 12, okay. Dv dx, this is very weird looking dv dx, is 6x plus 2, okay. And let's just piece that all together. So dy dx is u is x cubed minus 12x times dv dx is 6x plus 2, and then the other term v is 3x squared plus 2x times du dx, which is 3x squared minus 12. Now this requires a little bit of calculation. Essentially, what I'm going to do is just give you the answer here. So it is 15x to the power of 4 plus 8x cubed minus 108, which is x squared minus 48. X, okay. So you might not necessarily got terms in each, like we don't have a constant term or x to the power of 0 there. So that's it there. That's the derivative of that one. So quickly we'll do 23. Question 23 is as follows. Y equals 2x to the power of 5 minus x and 3x plus 1. Okay. Let's u equal to that, v equal to that there. Du dx is 10 times x to the power of 4 minus 1. Dv dx is simply 3, okay. And overall, dy dx is just piece that all together. I'll just actually rewrite out the equation here, just in case we've sort of forgotten it. U times dv dx plus v times du dx, okay. And let's just piece that all together again. What we have there is that is equal to 2 times x to the power of 5 minus x times derivative of v, that's simply 3, plus 3x plus 1 by du dx, that is 10x to the power of 4 minus 1, okay. And when you multiply that through and simplify it, again, it's just a little bit of sort of number crunching now. It is 36x to the power of 5 plus 10x to the power of 4 minus 6x minus 1. Okay, so that's a quick revision of the product rule for differentiation. Okay, and a couple of exercises there. So that's the answer to number 23.